scientists! This is Teacher Gab, and I will be your teacher adventure partner for our video lesson entitled Atom and its Subatomic Particles. The most essential learning competency in this lesson is to determine the number of protons, neutrons, and electrons in a particular atom. Before we proceed to our new lesson, let's test your prior knowledge about the subatomic particles.
Match the phrases in column A to the words in column B. Type the letter of your answer in the comment section. These are the correct answers. For number 1, the correct answer is D, proton. For number 2, the correct answer is letter E, electron. For number 3, the correct answer is A, neutron. For number 4, the correct answer is C, mass number. And for number 5, the correct answer is B, atomic number.
Did you get a high score? Well, let's learn more about this lesson. Are you ready? Join me and learn about atom and its subatomic particles. You learned in the previous lesson that all matter is made up of indivisible atoms. In this lesson, you will learn about the historical background of the atom and its subatomic particles, the differences among protons, electrons, and neutrons, and how to determine the number of electrons, protons, and neutrons. Atoms are the basic building blocks of matter. They make up everything around us. Your favorite book, the clothes you are wearing, the couch in your living room, and even the healthy snack you may be eating. Believe it or not, all those things are made up of atoms. In fact, everything in the world that you can see, touch, and even things you can't, such as air, is made up of tiny building blocks called atoms.
Atoms combine to form molecules, which then interact to form solids, gases, or liquids. Most elements in the periodic table exist as atoms. On the other hand, when atom is combined, a molecule is formed. Molecule is made up of two different or two identical atoms that are chemically combined. Let's take an example. The oxygen we breathe is made up of two atoms of oxygen. When three oxygen atoms are combined, they form ozone molecules. Water, or H2O, is made up of one oxygen atom and two hydrogen atoms.
For decades, scientists have been gathering evidence about its structure. Their studies led to the conclusion that atoms are mostly empty space, and they have three major subatomic particles, namely protons, electrons, and neutrons, that are held together by nuclear bonds to maintain the electrostatic attraction between the electrons and the nucleus. Atoms are very tiny. They could not be seen before scanning tunneling microscope were invented in 1981. However, the idea of atoms goes back to ancient Greece. That's where this brief history of the atom begins.
The history of atom begins around 450 BC with a Greek philosopher named Democritus. He first introduced the idea of the atom almost 2,500 years ago. He began the search for a description of matter. He questioned whether matter could be divided into smaller and smaller pieces forever until eventually the smallest possible piece would be obtained. He believed that the smallest possible piece of matter was indivisible. He named the smallest piece of matter atomos, meaning not to be cut.
Aristotle declared that all matter was made up of only 4 elements: fire, air, water, and earth. He also believed that matter had just 4 properties: hot, cold, dry, and wet. Around 1800s, an English chemist named John Dalton revived Democritus' early ideas about the atom. He performed a number of experiments that eventually led to the acceptance of the idea of atoms. He formulated the first atomic theory since the death of chemistry that occurred during the prior 2,000 years.
Dalton theorized that all matter is made of atoms. Atoms are too small to see, uncuttable, and indestructible. All atoms of a given element are exactly alike, and atoms of different elements are different. Dalton incorrectly thought that atoms are tiny solid particles of matter. He used solid wooden balls to model them. The sketch in this figure shows how Dalton's atomic model looked. He made holes in the balls so they could be joined together with hooks. In this way, the balls could be used to model compounds. When later scientists discovered some atomic particles, they realized that Dalton's models were too simple. They didn't show that atoms consist of even smaller particles. Models including these smaller particles were later developed.
The next major advance in the history of the atom was the discovery of electrons. These were the first subatomic particles to be identified. They were discovered in 1897 by a British physicist named Joseph John Thomson. Thomson provided the first hint that an atom is made of even smaller particles. He discovered the presence of a negative particle in the atom, the electrons.
He proposed a model of the atom that is sometimes called the plum pudding model. His theory was that atoms are made from a positively charged substance with negatively charged electrons scattered about like raisins in a pudding or chocolate chips in a cookie.
A physicist from New Zealand named Ernest Rutherford made the next major discovery about atoms. He discovered the nucleus. He performed an experiment using positively charged particles fired at gold foil.
Through his experiment, he proved that atoms are not a pudding filled with a positively charged material. He theorized that atoms have a small, dense, positively charged center, which he called the nucleus. He said that nucleus is tiny compared to the atom as a whole, because the atom is mostly open space. He concluded that the negatively charged particles are scattered outside the nucleus at a distance. Rutherford later discovered that the nucleus contains positively charged particles. He named the positive particles protons. Rutherford also predicted the existence of neutrons in the nucleus. However, he failed to find them. One of his students, a physicist named James Chadwick, went on to discover neutrons in 1932. In Rutherford's model, electrons move around the nucleus in random orbits. He compared them to planets orbiting a star.
In 1913, the Danish scientist Niels Bohr proposed an improvement. He built on the concept that the mass of an atom is contained mostly in the nucleus. He also theorized that electrons move in definite orbits around the nucleus, much like planets circle the sun. These orbits or energy levels are located at certain distances from the nucleus.
The theory has evolved over time, from the philosophy of atomism to modern quantum mechanics. According to today's atomic theory, electrons do not orbit the nucleus in neat planet-like orbits, but move at high speeds in an electron cloud around the nucleus. In the electron cloud, electrons whirl around the nucleus billions of times in 1 second. They are not moving around in random patterns. An electron's location depends upon how much energy the electron has.
That's it! Now that you know the historical background of the atom, let us now move